Hello, Flat Earth researchers, debaters and debunkers. Having studied the paths of the Sun and the Moon daily for more than 2 years, I am convinced from my own observations that the Sun and the Moon are both quite close to us. The Sun and the Moon both orbit above the stationary Earth. The Sun and the Moon are both of similar size. The Sun and Moon follow similar paths. Viewed near the equator, the Sun and the Moon both appear to flip after passing their zenith. They both pass overhead. Viewed from the north of the equator, both the Sun and the Moon appear to rotate clockwise. They do not pass overhead, they arch across the southern sky. Here is some footage of the morning sun from my backyard, looking east in Phuket. And here is the moon, taken from almost the same location. And as you can see, the sun and the moon are both following very similar paths. I see this happen every day. The sun comes up just over there, and then the moon comes up. So both the sun and the moon rise in the east, pass almost directly overhead, and then set in the west. Here we can see them side by side. Now, the sun is said to travel at varying speeds throughout the year, but the moon maintains a steady pace. So what happens is every month we see the sun overtaking the moon. So here's what really convinced me that the sun and the moon are doing the same thing. Here we have an illustration of the sun at different times as it rises in the east, and we can see 2 sunspots on the bottom of the sun. They stay there wherever they started out in the morning all through until midday, at which point we have to turn around and face west, and we watch the sun set. And when we turn around, those sunspots will appear on the opposite side of the sun from where they were when we were watching the sun rise. So this is just like an object flying over our heads. Now, when we compare that with the moon does exactly the same thing. We can have those spots as markings on the moon, and when we look east from Phuket, those markings on the moon and the shadow on the moon, if there is one, will remain in the same place until the moon reaches its zenith. And then we turn around, just like we did at midday with the sun, and we watch the moon heading off to the west, and all the markings on the moon will have flipped, and we are now looking at an upside down moon as it goes off into the west, just the same as an object flying over our heads. And here is how the sun rises and sets when viewed from the UK, looking southeast to southwest. And we can see here that the sunspots from 7 a.m. until, say, 5 p.m. are rotating with the sun, apparently. And we also get exactly the same thing with the moon when we watch the moon go across the sky from the UK. There is no dramatic flip like there is in Phuket, and it's just the same as the sun in the second case. And as I was saying earlier, what happens is when the moon is doing a constant speed and the sun is doing variable speeds, we end up with the moon sometimes in the sky at the same time that it is daylight. This will happen at least once a month. So to me, this all makes sense in the flat Earth model, and I'll leave you with that footage of the sunspots taken in Phuket and the... So here we have the sun in the morning from my east-facing balcony. Of course, being on the equator, the sun comes directly at you from the east, and you can see the sunspots at the top there. Now, I filmed this through glass for a welding mask, and here we are 1 hour later. You can see that the sunspots are pretty much in the same position at 8 o'clock. So I continue to film at kind of hourly intervals throughout the morning, again 2 hours later. So the sun is already much higher in the sky, or appears to be, and the sunspots, you can see there are no other sunspots but just the ones on the top there. Alright, 4 hours later, so 1 hour before midday, and the sunspots are still pretty much in the same position. And of course, I'm just near the equator, so the sun does arc slightly. Now here I am looking directly up at midday, and the sunspots have kind of appear to have moved in a clockwise direction, but that's normal. Now 12:45, we can in a minute see that those sunspots are now at the bottom. So I've already turned around and now facing west, but still looking up, but facing west to see those. So whoop, they have flipped to the underside. Apparently, that's how they appear, just because I've had to turn around, but essentially they are still in the same place on the sun. And now that the sun has gone overhead, now it's 3 o'clock in the afternoon, so I'm having to face west from the west-facing balcony as the sun goes away from me, and you will see that those sunspots are still on the underside. There we go. Okay. Alright? So they haven't really moved on the sun, they've stayed in the same place, it's just the viewing perspective that has changed from east to west. Alright. Okay, so here we are looking at the sun just after sunrise, 7:30 in the morning, facing east-southeast from the UK. So in Phuket we were facing east, now we're facing east-southeast, and there we have a pair of sunspots at about the 7 o'clock position on the sun. There is another one just up to the right there, but we'll focus on the pair of sunspots there because they are easier to follow. You have the second shot of the day taken at 11:30 in the morning, and you can see that the sun has moved across the sky, but it's nowhere near going overhead. And this time the sunspots have rotated clockwise to about the 8 o'clock position on the sun. You can see them there now. Okay, so there's already been some rotation between sunrise and before midday, whereas while looking east in Phuket we had no rotation whatsoever. So I just thought I'd give you a panoramic shot from where the sun rose and the path it's taken until this is about just gone 1 o'clock in the afternoon. A bit of a problem with the clouds there, and you could see it was going to be cloudy for the rest of the day. So I just about managed to squeeze this one in, and very faint, but we do manage to see the sunspots at that kind of 8-9 o'clock position on the sun. And that's as much as I was able to do on that particular day, but it gives us a very good idea of the rotation that we are seeing of the sunspots during the day.